Jai Hind everyone, I am Achintya Pandey as Assistant Professor in Department of Information Technology at Ajay Kumar Garg Engineering College. Today I will discuss various technique of sorting method, right? Sorting technique, okay. This is one of the fundamental operation in data structure. There are so many operations like searching, sorting, deleting, inserting and all that. Okay, so here we will discuss this fundamental operation sorting techniques. So what is sorting? So sorting basically it is an operation by which we can arrange elements in a particular order. Either it could be increasing order or in decreasing order. Okay, so sorting is the process of arranging data in a particular order. And the order are either ascending or descending order. It improves searching and data analysis efficiency, right? Sorting can improve searching, like in binary searching, we sort elements. First we do, first we arrange in increasing order, then we sort, okay? Examples are marks, roll number and salaries, okay? We could arrange in a particular order, okay, depending on the applications, okay. So first type of sorting, there are in this lectures we will discuss the basic sorting technique, and mainly I will cover three techniques: bubble sort, selection sort and insertion sort, okay. So let's see bubble sort. So what is bubble sort? So in bubble sort we compare adjacent elements repeatedly, swap if they are in wrong order, largest element move to the end after each pass. This sorting method is simple but inefficient for large data set. So we are going to just explore this bubble sorting technique, how we do. So there are n number of pass, okay, and after completing each pass or at each pass we get the maximum element, okay. So just one pass is complete, okay. After one pass the maximum element will be sorted out, okay. Then in second pass, second maximum, and third pass, third maximum, and so on. So after n pass inverse conditions, okay, we can sort all those elements. For example, let's suppose we have this element, okay, 94731, and we want to arrange in a increasing order using the technique bubble sort. So what we do? So in first pass we will compare first element with the second element, okay. If first element is smaller than second element, we will not swap that. If it is not so, say second element is smaller, so we will simply swap, okay. So here we see that 9 is greater than 4, or we can say 4 is smaller than 9, so we will swap this element. So this will become 4, 9, then 7, 3 and 1. Then this is the first pass, okay. In pass 1 we compare first element with the second element. If the second element is smaller, then we will swap. Again we will compare this second element with third element. If next element will be smaller, okay, then we will swap that, okay. So we see that this third element is smaller than, so again we will make swap. So doing so the list will become 4, 7, 9, 3 and 1, okay. So the point is here. Similar, we will compare these two elements, okay. Again we find that 3 is smaller, so there will be again one swap. So this will be 4, 7, 3, 9 and 1. Then we would have to think in next in next comparison we compare this two element. Again here 1 is smaller than 9, so we will make a swap 4, 7, 3, 1 and 9. So this maximum element, so just like bubble comes up, similarly the maximum element will come at its last position. So thus this one pass 1 is completed. So every pass, okay, if there are n element and say all the elements are in decreasing order, okay, so it could take n minus 1 comparison, right, okay. So after every pass, and every pass could at most take n minus 1 comparison inverse condition. So the maximum element will come at last. So now we would in next pass, okay, we will have to think about the list which will be one lesser, because maximum element should come at last position, and this has come. So the list will be reduced by 1, and the same process is applied. So pass 2 will be applied, to this list only, and the process is same. We'll compare first element with second element. If the second element is smaller than first element, we will make swap. Then again we compare second element with the third element. If third is, lesser, third one is smaller, then we will swap, and so on to the end of the list. So in doing so, we will get the maximum element at its right position, means at last position. So after n minus 1, so this list has been totally sorted out in pass 4. So after pass 4, we see that the list has been totally sorted out in increasing order. So this is the bubble sort. Okay. So in what we do in bubble sort, so there are 3 main point in bubble sort. First there are n passes. In bubble sorting, there could be various passes, and after each pass, maximum element will get its right position. Okay. So one pass may take at most n minus 1 comparison, maximum in worst conditions. Suppose worst conditions comes when the list will be already in decreasing order. Okay. So in the worst condition, it will take n minus 1 comparison. Okay. So after each pass, and there could be maximum n minus 1 pass. In the worst condition, there could be maximum n minus 1 pass, and every pass will have n minus 1 comparison, because the list will get reduced by 1. Okay. Because one element will, the maximum will get its right position, means at last. So the list will be reduced by 1 at every pass, and at maximum there could be n minus 1 pass. So its time complexity, if we will count, then it will come just as order of n square, because okay, this is the simple way just to find the time complexity of the bubble sort. Okay. So suppose if you want to find out, calculate the time complexity of bubble sort, then how we could calculate. So let's see how we find the time complexity. Okay. See, suppose if you want to find the time complexity, here we see in bubble sort there could be, suppose the element are in say decreasing order. So in decreasing order, it is the worst conditions. Why it is worst condition? Because maximum will at first position, while in arranging in increasing order, the maximum should at last position. Okay. So after every pass, we will get the maximum element. So suppose if, like here there are 5 elements, suppose there are n elements. So after each pass, we see that every pass will take n minus 1 comparison. So after one pass, the algorithm will take n minus 1 comparison. After second pass, the list will have n minus 1 element. So it will take maximum n minus 2 comparison. Okay, n minus 2. And similarly, in the next pass, it will take n minus 3. And at last, if there will be just 2 elements, then it will take just 1 comparison. So when we'll sum, the summation will be sigma n minus 1, and its value will be n plus 1 by 2. N is here n minus 1, and n plus 1 by 2. So n minus 1 plus 1 divided by 2. So we see that this comes order of n square. So all, I mean, we will see that this fundamental sorting technique will have the time complexity in general order of n square. Okay. So the process of bubble sort is quite simple. There are n passes. At every pass, we get the maximum element. What we do at every pass, or in every pass, we just compare first element with the second. If second one is lesser, or you can say first one is greater than second one, then we will make swap. If it is not so, then we will simply compare second with the third, and if the next element is smaller than the previous one, we will make swap. If it is not so, we will not make swap and compare with the next element. Okay. So doing so, we get the maximum element at last. Okay. So after n minus 1 pass, we will the entire list will be sorted out. So this way is called bubble sort, and time complexity we have seen that the order of n square. Now what selection sort. So what we do in selection sort? In selection sort, we find the minimum element. Okay, there are, suppose there are n number of elements. Okay, so we have the algorithm to find minimum element. So we will find the minimum element, and we get the position of that minimum element. We simply swap with the first element. Okay, so the minimum will come at first position, and the first element will come at where the minimum was in the list. Okay, then so here we get the minimum at first position. Okay, so again we will have the list of n minus 1 element which will not be sorted. In that n minus 1, we again find the minimum and then swap with the second element, and so on. This is the method. It will also take order of n square. Okay, so let's see. This is the list. And we want to apply the selection sort. So what we do, the process say that out of this, suppose n element, we get the minimum. Here the minimum is 13. So this minimum element will be swapped with the first element. Okay, so 29 comes here, 13 comes here. Okay, sorry, not 13. Here minimum is 10. Okay, so 10. Okay. In selection sort, what we do? We find the position of the minimum element. And what is the minimum element? Okay. So here the minimum is 10, not 13. Okay. So we simply swap with the first element. So here 10 and this one. So we got the minimum, and that minimum should at first position. So in the next pass, in the next step, what we do? We would have n minus 1 element which has not been sorted. So we get here the minimum. In out of these n minus 1 element, the minimum is now 13. So this minimum element must be swapped with the first element of this list, new list. Okay, so the 13 comes here. Okay, and this 29 will be swapped with this position. Okay, so after step 2, the list will be reduced by 2. So we will have n minus 2 element. In n minus 2, again we find the minimum, and here in this minimum is 14. So it will interact at this position, and so on. So this is the quite simple way just to sort using selection sorting method. The process is simple. We get the minimum, find the minimum, swap with the first element. Okay, and then we will have list of n minus 1. Again we will find the minimum in n minus 1, swap with the first, and in doing so, we get the sorted list. Okay, so this is called selection sort. Okay, this will also take the time complexity of, suppose there are n element and we get the element is say already you can say in decreasing order. So minimum will be at last position. So we will have n comparison, n minus 1 comparison. Okay, by visiting nth position, it will take n minus 1 comparison. Okay, or n, then we will swap with the first. Again we would have n minus 1, again the n minus 1. Okay, so the time complexity will be same, n plus n minus 1 plus n minus 2 dot dot up to 1. So sigma n, that is order of n square, if we will calculate that. So time complexity of selection sort will also be order of n square. Then we have insertion sort. Insertion sort is just simply, you can think just like we insert an element into an array. So builds sorted array one element at a time, similar to arranging cards in hand, efficient for small or nearly sorted data, adaptive sorting technique. So let's understand with the insertion sort with this example. Suppose the list is 12, 11, 13, 5 and 6 and we want to apply insertion sort. So one by one, what we do, say in first step 12, there is no element before 12. So as a single element is already sorted. Okay. Now 11. Now we have two element. Okay. So 11 and 12. Yes, this should be inserted here, and just like we insert element into array. So if we get the right position of that where the element is to be inserted, we simply shift up or shift down. Okay. Same case here. Suppose if we have two elements, 12 and 11, so 11 should come here. So this would be simply shifted up. Okay. So 11 and 12 will come like this. Then we have 13. 13 is already at its right place. Okay. So 13 will be inserted at this. 5. Now we will have 5. So 5 is smaller than all. 11, 12. So 5 should come here. So from this point, our element which is already there, they must shift up. So 5 will be, and both will be shifted up. So here the rest, once we get the position of next element which is been encountered, from that positions, all the element will be simply shifted by just right position. Okay. By one right position. Okay. So like 5 will be at this position. So this existing element 11, 12, 13 must be shifted just by 1. Okay. So 11 by 12, 13, everyone will be shifted just moving right by 1 position. Okay. So this will come. Similarly 6, we see the 6 should come here. So from this element, once the 6 will be there, every element after this second positions must be shifted up, or you can say must be shifted right by 1. Okay. So 11 which comes in second position, they would lying on third, 12 will be fourth and 13 will be at fifth in this list. So this way of doing sorting is called insertion sort. Okay. So this is the example. So bubble sort, this is some little overview of these sorting, bubble selection and insertion. So in bubble sorting, we do repeat comparison and swapping until sorted. In selection sorting or selection sort, we select minimum element and swap. In insertion sort, insert element at correct position. Okay. So we insert element at correct position, and from that element where it's been inserted, rest element will be shifted up or shifted right just by 1 position. So in bubble sort, the base time complexity is order of n. If the element is already in, say, increasing order, then we will simply take order of n. Average or worst case time complexity will be the order of n square. In selection sort, in all cases, we will get the time complexity order of n square. In insertion sort 2, we get the base time complexity will be order of n. When it is already sorted, there will be no position to be shifted. They will be just intact, and so the time complexity will be order of n. While in worst case, it will also take order of n square. Okay. So this is the time complexity of each algorithm, especially bubble selection and insertion sort. Comparison of sorting algorithm. Bubble sort is easy to understand. It is very slow. Selection sort will have minimum swap. It is not adaptive. Insertion sort will be fast for small data set. Okay. If they are not used data, so it will be fast. Okay. For a small data set, this insertion sort is simple and efficient. So out of these bubble selection and insertion sort, we get insertion sort be simple and efficient way. Okay. These all are some application of these fundamental sorting. Sorting student marks, ranking system, database indexing, pre-processing data for searching. Okay, these all are the applications of we can apply. I mean bubble selection or even insertion sort in doing these kind of applications. Okay. So this is the conclusion. Sorting is a fundamental in computer science. Bubble selection and insertion sort are basic algorithms suitable for learning and learning small data set. Advanced sorting is used for large data. Okay. For a small data set, we can do this kind of sorting, but for large data set and depending on the arrangement of how the data are arranged, these sorting are not applicable. We will have next. There are many other sorting too. Okay, that could be used. Okay, so this is all about the sorting technique. Thank you very much.